All right, guys, I got to adjust this, so give me just a minute. Sorry, but I had to put it playing and then it has to adjust. I need to get it more in focus, I think. Make sure everything's focused in there real good. All right, so as promised, here is the video going over the similar figures and scale factor. I'm going to jump right in because I don't want this to get too long, okay? Similar figures have the same shape, but different sizes. Same shape, but different sizes. Yeah, I got to learn how to spell. All right. One word that you're going to see a lot, and we were looking at some problems this afternoon in tutoring, and the word is congruent. And I think it's on here somewhere. But congruent means equal. Congruent means equal. And similar figures are never going to be congruent. Similar figures are not going to be congruent. They're going to be similar. Similarity and congruence are not the same thing. Congruence is the exact same. Same shape, same size, everything is the same, okay? So a lot of the multiple choice answers that you're going to see on the assessments that we've got coming up are going to try to throw you off when they say the two triangles are congruent. They're not going to be congruent. We hadn't done anything with congruence. They're going to be similar. So just kind of keep that in mind. The corresponding angles are, this is where the word congruent goes. Because the angles will be congruent, but the corresponding sides are going to be proportional. And that's why we're doing this during this unit, because we're looking at that proportion. Proportional relationships is everything in this unit. A scale factor is the ratio of length on a scale drawing. If the scale factor is less than 0, then 1, the figure's going to get smaller. And if it is greater than 1, it's going to get bigger. Now, we talked about this is a ratio. This is the ratio that we'll be using, model over actual. But we're also going to be using the ratio new over original, because some of the problems don't lend themselves very good to the model over actual ratio if they're not talking about a model. And so we use the ratio of the original over new over original because it lends itself a little bit better to what we're having to find, okay? Okay, so find the scale factor of the model sailboat if the scale is 1 to 6. Now, if we're just finding scale factor, 1 inch to 6 feet, the model would be over actual, it would be 1 over 6, so the scale factor would be 1/6. If we're looking for this scale factor, the model over actual, 1 inch to 2 feet. The reason I know, this is the scale. A scale will always be written model and actual. Model and actual. A scale is going to be written that way. So when you're given the scale, you can take that and determine the scale factor. All right? Now, I'm going to come right up here and do a few more little additional notes on some things that we want to keep in mind. When we're setting up our bridge maps, whether we're using model or actually new or original, I want you to keep in mind that you have 2 ratios right here. This is going to be 2 ratios. And what I'm calling these, we have our given ratio and our missing ratio. The given ratio is going to be information that you are going to be given. Sorry, I just kicked the... You are going to be given in the problem. The problem's going to give you enough information to set up this ratio. The missing ratio is the one that's going to have your variable in it. Okay? The missing's going to have your variable in it. So if we look down here at example 3, a model rocket was built using a scale of 1 to 15. That's going to be your ratio. That's going to be your given. Okay? So if we use model over actual, this is my given. So I get 1 to 15 right here. If the height of the actual rocket is 9.9, my actual rocket is 9.9, meaning that the 9.9 has to go here because that's where my actual goes, and then x goes there. We cross multiply. 15 times x is 15x. 1 times 9.9 is 9.9. Divide both sides by 15. And x is going to equal 0.66. I'm pretty sure that's what it is. I think that's what I remember. I'm going to check it. Yep. Okay, so 0.66 is the height of the model in millimeters. So we could say the model is 0.66 millimeters. Or you could say the model's height. The model's height is 0.66 millimeters, okay, because it said height. Okay. A backyard playhouse was designed after a real house using the scale of 3 to 5. So, coming right here, model and actual. This is our scale, that's our given, 3 to 5. If the ceilings in the playhouse are 6 foot tall, the playhouse, this playhouse, that's your model. Because it ain't as big as a real house. If the ceilings in the model are 6 foot tall, how high are the ceilings in the actual house? The actual house is what we're looking for. So our x goes here. Cross multiply, 3 times x is 3x. 6 times 5 is 30. Divide both sides by 3. And x equals 10. So the ceilings in the house sorry, I had to make myself some. Actually, I'm sorry, y'all. I got to back this up a little bit. I don't have enough room to write. The ceilings in the house are 10 feet, which is about what a real ceiling is. They're about 8 to 10 feet. Okay. Now, solve for the missing side length. Okay, now we're getting down to looking at using new over original. Because this does not give me a model and an actual, we're now looking for, we're going to use new and original. Now on these, I'm just assuming, I'll be honest with you, that this is my original, this is my new. And that this is my original, and this is my new. Most cases, it's going to be left to right. Most of your problems are going to tell you something that will let you know which one's the original, which one's the new. But we're just going to make that assumption for these. In order to use these, we've got to use corresponding sides. We've got to use those corresponding sides. This side 12 right here corresponds with this side 3. And that is going to be our given ratio. And that's new over original. This is going to be our ratio for given, because we're given both of those things. So 3 over 12. And then our missing is x over 20. Cross multiply, 12x equals 60. Divide both sides by 12. And x equals 5. X equals 5. Okay. Right here, you've got several options as far as which ratio you're going to use. I'm going to color code them. I'm going to color code them for you. This 90 corresponds with this 10. This 36 corresponds with this 4. This 126 corresponds with that 14. You could use any one of those pairs as you're given. You could use any one of those pairs as you're given. Okay? New and original. I'm going to go with the 10 and the 90, but you can use any one of those pairs. But 10 over 90, and then this 7 over this x. So 10 times x is 10x. 7 times 9 is 630. Divide both sides by 10, and x equals 63. Sorry. All right. This was my missing. Again, I just assumed that this was the original, this was the new. I had no way of knowing. Most all of your problems are going to give you that new. They're going to give you something from the problem that's going to help you get to there. And I think you'll see that on some of these on the back. All right. So, looking at these up here at the top. On these, this one, we're not looking for missing side. It's just asking us for scale factor. All it's asking us for is scale factor. And so we just have to write a ratio. All right? All it's asking me for is this. So it's asking for that ratio. The ratio of new over original. Okay? The way I know that this is my original and this is my new are these hash marks right here on this. A prime, B prime, and C prime indicate that this was where I started and I changed it to this. This is ABC and then A prime, B prime, and C prime. That is how you indicate that in the mathematics world, okay? So let's look at our corresponding sides first before we do anything else. This is side AB. It corresponds with side A prime, B prime. Notice how that triangle has been shifted around. You've got to be very careful in how you make sure you are getting those corresponding sides. This is side BC. This is side B prime, C prime. And this is side AC. And this is side A prime, C prime. And those are your corresponding sides. So I can set up a ratio from any of those, and I'm going to get the same answer. So what I'm going to do is I'm going to do all three ratios and show you, and then I'm going to color code them back. We've got to do new over original. So new over original. So 9 over 12 will simplify to 3/4. And that's using those two pink sides. Okay? That's using those two pink sides. 12 over 16, it's going to simplify to 3/4. We used these two yellow sides to do that one. $18 over 24 simplifies to 3/4. And we use that blue side to do that one. You don't have to do all three. You just need one. You just need one. But notice every one of those had the same ratio in the end. So down here, K equals 3/4. All right? Okie dokie. Now, this is where it gets a little wonky. All right, so trapezoid ABCD is dilated to WXYZ. Dilated means it got bigger. So it's telling us in this question that we went from trapezoid ABCD was dilated to become this one. So this was my original. This is my new. Okay? And I told y'all, but also that ain't sitting in the same, it ain't sitting the same way, so it's hard to see what corresponds where. Okay? So what I want you to see first is that, let me change my color right here a minute. I told you yesterday, A, B, C, D, W, X, Y, Z. You can assume that you can add those up. You can line those up that way. We can line those up that way. So this is A. This W is going to correspond with that. For my sake, I'm going to make that A prime. And this is B, so X is B prime. I'm going to change them. I like having the A and A prime, B and B prime because it's much easier to see those sides. C, so Y is C prime, and this is D prime. If you rename them, and nobody can, I mean, it doesn't matter that you're renaming them. You're doing, that's just a strategy. All right? So now we can see that AD right here corresponds with AD right here. AD, A prime, D prime. And AB right here corresponds with A prime, B prime right here. And BC corresponds with B prime, C prime. And DC corresponds with D prime, C prime. Again, you can use any one of those links. You can use any two. Any pair will give you the correct scale factor if you've got them paired up right. I'm going to just use AD and AD. So new is 10. Over original is 5, meaning the scale factor is 2 over 1, which is 2. But any of those would work. Okay? What is the scale factor for the pentagon below? This one is written in primes, and so that's easy. I like it when it's already written in primes. So LP right here is L prime, P prime right here. LM right here is L prime, M prime right here. PO is P prime, O prime. MN is M prime, N prime. Oh, what color do I need? I guess I could use an orange, couldn't I? I don't have a good orange. I guess I use that red. And then this one goes with this. All right. We only need one. We only need one. So I'm going to just go with 6. PL. LP. I'm going to go to the blue one right here. So this is new. This is original. This is new. I know that because of these primes. The prime on these letters tell me this went from here to here. Okay? So, 9 over 6 is going to be 3/2. And I'm just going to leave it like that. And that is the scale factor. We could take it on to 1 1/2 if we wanted to. But for the most part, that is the scale factor. All right. Triangle A. All right. First of all, we're going to triangle ABC. This is written backwards. I don't care what anybody says. This triangle was dilated to this. That question is not written correctly. So we're just going to ignore that question and know that this triangle was dilated to this triangle. But we have E, F, or D, E, and F. We got to put them in order. We got to put them in order, D, E, F. They got to be in alphabetical order. And we have ABC. We can assume that those vertices line up, that they are corresponding, and they are. Those are corresponding angles. Those angles do correspond. But because I don't like having them different, I'm going to say, okay, D corresponds with A. So here's D. I'm going to make A D prime. And E corresponds with B. So I'm going to make this E prime. And I'm doing it like that because this was my original. This is original. This is new. The new one always gets the prime. And F corresponds, so this is my F prime. It's just going to make things a little easier when I'm trying to get those corresponding sides. So now side FD corresponds right here with F prime, D prime. EF corresponds right here with F prime, E prime. And ED corresponds right here with E prime, D prime. And I just need to use one. So I'm just going to pick that 10, FD, and that 25. And I need my new over original, so 25 over 10 is going to be 5/2. And I would just leave it like that. All right. So, yesterday I told you when we were doing this that one of the words that you're really going to have to watch out for, and one of the words you're really going to have to be on the lookout for, is this word right here, dimensions. Dimensions. Anytime you see the word dimensions, you are going to be looking, you're going to end up needing two or more ratios or bridge maps, proportions. Because if we're looking for dimensions, we're looking for at least a length and a width. We're looking for a length and a width. So I've got to do 2. Because my given is right here. 1/2 to 2. So to find this one, this is model over actual. So to find that, the side that is 3, to find this, if this is our width, then to find the actual width, I've got to set up the proportion to find the width. So I'm finding just the one, I'm just doing the 3 right at the moment. So 1/2 x equals 6. Divide both sides by 1/2. And x equals 12. Well, then I have to come here and do this 7. So I'm going to use the same given. 7 is the model. 1/2 x x equals 28. All right. Now, An artist is painting a large mural of flowers on the side of the school. If she uses a scale of 4 inches to 1 inch. So we're doing model over actual, 4 inches to 1 inch. That's my given. How large would the mural painting be if the rose bloom, if the actual height, that means that the actual height is 6 1/4 inches. It's going to go right here with my actual. The X is going to be what's missing. On the X, sorry, y'all, on the model is what's going to be missing. I'm yawning like crazy. The X on the model is what's going to be missing. So, cross multiply. We get X equals, and 4. I want to tell you something, guys. 6 1/4. I know that's 6.25. So I'm going to put that in my calculator, 6.25. I'm not putting it in as a fraction if I can help it. 25. So the actual height of the mural, or the mural height, which is our model, would be 25. If a blueprint is drawn using a scale of this, if my bedroom is 12 foot by 14 foot, what are the dimensions? There it is. There it is. There's that word, dimensions. Dimensions means I'm going to have 2. I'm going to have 2. I'm going to have 2. So let's just go and set them up. There's 1, and there's 1. I don't even know what length and width. They're not even talking about length and width now. They're just giving me numbers. Well, my given is right here. My given is right here. There's my given. So 1/2 to 6. I got to do the 12. All right, so we're looking for the bedroom on the blueprint. The bedroom on the blueprint, which means this is the model. So the X is the model. So this 12 is going to go right there because that's the actual height of the bedroom. I'm going to erase this one so I can. 6 times X is 6X. 1/2 times 12 is 6, I think. Is 6. Divide both sides by 6. X equals 1. So the dimensions on the blueprint would be 1 inch. Now we look at the next one. We're going to use the same given. And now we've got to use that 14. X is going to go in the same place. So we're going to do 14 right here. 6X equals. I don't know why I'm yawning so bad. Divide both sides by 6. Is 1.66 repeating. So X is 1. We'll just round it to 1.7. Round it at 1.7. Tried to wake myself up. Now we got just a few little proportions down here. We're just going to cross multiply and get the answer. 2 times X is 2X. 4 times 7 is 28. Divide both sides by 2. And X equals 14. X times 7 is 7X. 5 times 56 is 280. Divide both sides by 7, and X equals 40 divided by 7 is 40. Why am I so sleepy? Oh my gosh, y'all, I'm sorry. All right, so right here, I told you yesterday, when you have an expression on top like this, we've got to treat it like it's got parentheses around it. We got to treat it like it's got parentheses around it. So when we cross multiply right there, that's really, I'm going to change my color so you can really see that. That is really 18 times x minus 1. So 18 times x is 18x, and 18 times negative 1 is negative 18. So this 18x minus 18 is what you're going to get when you cross multiply that. Then we cross multiply 6 times 12, and we get 72. Now we got a little equation to have to work. So we add 18 to both sides. 18x equals 90. And divide that by 18. And x equals 5. And this last one, we're going to put parentheses right here. Cross multiply this. When we cross multiply this, we're really multiplying 6 times 5x minus 15. So 6 times 5 is 30x. 6 times a negative 15 is 6. Is a minus 90. That, now we're going to set that equal to 18 times 10 is 180. And again, we've got a little equation to work. So here's what I'm going to do because I'm running out of room. I'm going to come right over here and pull that equation. 30x minus 90 equals 180. And work it right here. We're going to add 90 to both sides. 30x equals 270. Divide both sides by 30. And x equals 9. And I'm going to do that on here just because I'm so daggum sleepy. I don't know what's wrong with me. I hope I ain't getting sick. And there it is, 9. All right. Number 12, a scale of a map is 1 inch by equals 70. If two cities are 5.5 inches apart on the map, they're this far apart on the map. The map is a model. That map is a model. How many miles are they actually apart? Okay. How many miles are they actually apart? So our given is 1 inch to 70. This is our model and our actual. So the map is our model. So we're 5.5 inches apart on the model. And we're looking for how far apart they actually are. 1 times x is x. 70 times 5.5 is 385. So they're 385 miles apart. Okay. A blueprint of a house is drawn using a scale of, there's your given. If the bedroom of the actual house is 16 by 12, oh Lord, here it is again. What are the dimensions? There's that word again, dimensions. When we see dimensions, we know we're going to have 2 or more bridge maps. So, let's do the first one. Here's my given, 1/4 over 3. And we're going to use that 16. We're looking for the bedroom on the blueprint, so we're looking for the model. We don't know the model, so my 16 goes right there. Cross multiply, 3x equals 1/4 of 16 is 4. Divide both sides by 3. And that's 4/3, which is 1.3 repeating, which is about 1.3. All right, I hope I did that right. Something feels weird about that. If the actual house is 16 inches by 12. Yep, that's it. Now, we got to do it one more time. 1/4 and 3. If the bedroom of the actual house is 12, now we're using this 12 over here. Now we're using this 12. And it's in the actual house, so that's going to be an X. 3 times X is 3X. 1/4 times 12 is 3. Divide both sides by 3. And X equals 1. Wait, no. Yeah, X equals 1. Okay. Just a few more. The scale of a map is this. All right, so here's our model over our actual. A map is going to always be your model. A map is going to be your model. So here's my given, 5 to 15. The map, they're telling us 25 is on the model. What is the actual? So 5X equals 15 times 25 is 375. Divide both sides by 5. And we get 75. So this is 75. Right here, the scale factor for the model is, all right, so now we want to know what the scale factor is. So we're going to take the model, 24.4, over our actual, 48.6. And we get 0.50. All right, hold on a minute. Hang on. I hate these. I hate these problems. Let's fill this in. We got to put this back in our bridge map. But it's going to go in a different place. This one's going to be kind of weird. Okay? Watch. Model, model. So I'm going to put 12 here and 24.4 here. Model, model. It's all got to go right there together. Actual, actual. And we're trying to find that. We're trying to find that. It all fits in the bridge map. I don't know what I was doing a while ago. I told y'all I'm not sure what's going on with me. 24.4 times X is equal to 12 times 48.6 is 583.2. And we divide that by 24.4. And X is going to equal 23.9. That's what we're going to call it. 23.9. That was kind of weird because it left out, I hardly ever see that, but it left, your missing was in the given ratio, which is crazy. I don't think you'll see any more like that, so don't sweat it. That's just, the missing was in the given ratio, which goes all the way out there in left field. But it can happen, but I don't think it won't happen. Probably it won't happen again. Here's our given, 6 and 18. The map is our model, so 6.6 and X. 6X is equal to 6.6 times 18 is 118.8. Divide both sides by 6, and it's 19.8. So 19.8. All right, here's another one like this one, but I promise you, I promise you, I don't, you're not going, I don't foresee you seeing any like this, but should you will have done them. Set up your bridge map. This is model and actual. All things model goes here, all things actual goes here. What this is doing is it's leaving out one of the pieces of the given. So this is 20 centimeters, and we don't know that. But our model is 46.6 right there and 60.6 right there. So it's actually giving you what's over here now. So basically on the problems like this one, like number 15 and number 17, this becomes your given and this becomes your missing. And to be honest with you, I mean, those two things can be fluid. It can be on either side. You can have a missing on either side, but you typically don't. But it can happen. It can happen, as you see. 46.6 x equals divide both sides by 46.6. And we get 26.008, so we're going to call that 26. So, on number 15 and 17, they flip-flopped your given and your missing. So, putting it in the ratio, this was the model, this was your actual. But we didn't know what that one was to start with. So, go through this. Let me know if you have any questions. I'll take a quick Q&A tomorrow before we get into the daily grade. I am going to kind of help you through the daily grade and talk you through some things and give you some pointers and get you feeling pretty good about it. It is a daily grade, so don't sweat it. I'll upload the key in just a few minutes. I'm going to get the video processing and uploading, and I will see you tomorrow. It is Friday tomorrow. Woohoo! See you guys.